Okay, question 1. You're drawing from a deck of cards, getting a red. So how many red cards are there in that deck? Reds. Half of them are red. How many face cards are there in that deck? 12. There's an or. So what are we doing? Adding. When you did this, was there anything that you overlapped and double counted? Yes. So we're going to have to take away some overlap. So which cards did we count twice? The Jack, the Queen, and the King of Hearts and Diamonds. Okay, so what's that? 6 cards? So what does this make altogether then? So that was 32 cards possible. And what do you always do as a probability? Out of the all possible. Okay, and you can leave it as a fraction. You could have wrote it as percent. Drawing a 5 or a 10 from a deck of cards. So how many options do you have to pick a 5 out of that deck? How many of those are there? It's 4. How many 10s do you have in that deck? 4. What does the word doing this or that mean? Add. Is there any overlap between 5s and 10s? Nope. So we don't have to account for that. Okay, but did that make sense that there was an overlap with red and face cards? There's an overlap in there that you're double counting a card. Okay, rolling a 1 on a die. So what's the probability of getting that 1 rolling? It is a 1 out of 6 chance. And what do you do if you hear the word and? Times, and then a flipping ahead, 1/2. So 1 out of 12. Flipping 4 heads in a row. So you're trying to get a head, head, and a head 4 times. A half. All of them are a half, right? Each time you do a coin, it'll be a half and a half. What kind of math are you doing with all those? You're multiplying because you're trying to do all of it, not this or that. I'm trying to do this and then this and then this. I'm trying to do that. Okay, a bag of marbles. How about before we even start the question, tell me how many marbles are in your bag altogether. Did you get 19 altogether there in your bag? Okay, so we're going to draw 2 red. So we're going to be doing a red without replacement, without. So we put it in our pocket and then we draw again. So red, would you agree that's 8 out of 19? Times, right, because you're doing this and that. So we didn't replace it. So now this would be 7 and this would be 18. So this one says we want to draw 2 greens, so we want to go green, green. But we do replace it. So we had 4 greens in there. So 4 out of 19. That's the first draw. And then I put the marble back. So on the second draw, I would have the same chances, right? Drawing 2 marbles of the same color. So this is a scenario. Think about what could be a possibility. You could be getting a red-red situation, that's the same color. Or green-green, or blue-blue. We're going to add the situations because it's a different scenario. Without replacement, would you agree the bottoms are always going to say 19 and then 18? Right? If we do not replace, the first draw there was 19, and then on the second draw there would always be 18 then. And then these will always also go down. So reds, 8 and then 7. Okay, without replacement, they go down. That was good. We got a match with somebody. Okay, rolling 2 dice. There is a very specific strategy I showed you with this. What is that strategy? Anybody remember? I see people saying do that. Rolling 2 dice and trying to think about the sums. Okay, and then you go through and you're looking for anything that would be even or divisible by 5. Okay, so this is a situation where there's a bunch of even, there's a bunch that are divisible by 5, and these were the overlap, but you can either do all my yellow plus all my pink minus those 3 overlap, or you can just say how many have I just highlighted all together. So 1, 2, 3, 4, 5, 6, 7, 8. Is there 22? Is that what you got? Okay, that one would always be out of 36 options. The chance of getting a good yield on your farmland this year is 70% if you had a 2-inch rain in July. And the chance of getting the 2-inch rain is 65%. Da 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 da. What strategy is this one? The V's? Yeah, it's the V outs. So what depends on the other? Does your farm produce depend on rain, or does rain depend on your farm? That doesn't even make sense. So we need to put the rain before, right? We need to do rain or not rain, because the farm stuff depends on the rain. So then that comes next, right? A good yield. Okay, so this is actually the first thing I want to really look at. The chances of getting that 2-inch rain in July is 65% chance of that rain. So 65% chance that you would get that rain, which makes not getting that rain, got a number on that? 35? Okay, now I'm going to actually go back to the top sentence. Getting a good yield, you have a 70% chance if you had that rain. So if there was that rain, the good yield is a 70% chance, which means 30 not. And then the last part, the chance of getting a good yield, if you didn't get that rain, now you're only going to have a 50% chance. So then this one would be 50-50. This is a day that some of you were gone. There was like 7 of you missing this day that we did this. Okay, can you times each branch? What do all those add up to if you just added them all up? 1, right? Okay, what's the chance that you would have a good yield? So this was a situation I had the good yield with the rain, and here's the situation I had a good yield without the rain. So what kind of process are you going to do there? You're going to add those numbers. Okay, you can leave it like that. You could have stated 63%, whatever you wanted there. Okay, the probability of scoring a goal is 2 out of 11. So 2 times you would score, right? 2 times you score out of 11 shots. So how many shots would you miss? Right? The 11 is the total. So you either make it or you miss it, right? So what are the odds against scoring a goal? So I need this as a semi or whatever, a colon. So the odds against scoring. So what do you have to write first? You have to write against scoring. So how many times did you not score? 9. How many times did you score? Okay, please remember when you do these ones, the odds, that these two always add to the total, right? The odds of getting to work on time is 1 to 4. Which means this would be how many on times you do, and then this would be how many lates you do. On time, not on time. What is the probability of getting to work on time? So how many on times were there? 1 out of how many times did you go? 5. So remember again, every time you have that colon thing, the 2 in there, add to the total. Your family is lining up for a photo. You have 6 members with 2 parents, 4 children. What is the probability that the parents will end up beside each other in this photo? Okay, so here's my 6 people. I'm putting them in a photo. Think about the parents sitting beside each other. What do? You chunk them together. How many items move around now? There's only 5 movements now. What can the parents do beside each other? Bless you. So this is this situation, and you always divide it by what is the all situation if I didn't have any placements and I didn't care. Okay, so I just want to show you this feature on this calculator. I don't know if some of you know this, but okay, there. Did you know that you have a feature that can just reduce into fractions for you? So under this button called Math, there's right away fraction, and it can turn anything into the best fraction for you. So just a feature, but you can leave it like that. You see it?
What did you just do?
Math. And then there's fraction, and it will just turn anything you've done into the best fraction. So like if I do 5/20, right? That's in a decimal, math, fraction, and it'll just turn it into the reduced fraction for me. Okay, basketball. When you put a basketball team on the court, how many players need to be playing in that basketball game from your team? 5. Knowledge about life. Baseball. How many people are on the field? No. Baseball. That is 9. Life. This is life. Volleyball. How many people are on? 6. Hockey. 5 plus a goalie, so 6 depending on what we're talking about. Whatever. Okay. Life. Okay. Okay, so we have 6 boys, 6 girls. What's the probability that 5 girls would be chosen from this starting lineup? Okay, so let's think about this. We want to pick 5 girls to put onto the court. Do you care about the order of this? No. So what do you do if you don't care about the order and you're just trying to pick people? Choose. So we want to choose 5 girls from 6. You don't need to write this, but I'm going to also choose no boys. Like, you don't have to write that, but there could be scenarios where you're also choosing boys or something too. Okay, so I'm choosing 5 girls from 6. Technically, I'm choosing no boys on this committee. Out of, if I didn't care what I was putting on the committee and I just needed, or on the committee, on the team, on the court, I just need to put 5 people on there. So what should I do if I don't care in the whole situation? What could I do? 12 choose 5. Oh, that's low. Bless you. Did you get a really low number? Yours gave you a scientific?
Yeah, mine does too. Whenever I do these ones, it always is scientific and I don't know why.
Is there a mode? Are you in a scientific mode? Maybe I'll check your calculator out. Okay, there's 120 students in grade 9. The probability that they take music, 50%. The probability sports, 60. Once you read this, do you have an idea of what the strategy? Venn diagram. Okay, so big thing is recognizing that. Give me the universe. We have, what do we have? Music and sports. Okay, don't participate is 10%. That's where I would start. So no one, so that's on the outside, 10%. Leaving me with how much can I fit in the inside of these bubbles? There should only be 90% in there. But there was 50 with music plus 60, which is 110%. So how much over was that? Did you put 20% overlap? Okay, so now music is 50, so there's 20 plus 30. And sports is 60, so 20 plus 40. So now, how to do the question. This is a little bit different. I don't think we've seen many of these. How many students participate in only sports? So this is what I'm looking at, 40%, but that's not your answer. How many students? So what do you do with that? 120 students, 40% of them. So you got to do that, okay? So there's 48 students that do that. Okay, does that make sense though, that little extra step? 40% of the students. So then you have to figure that one out. You create a PIN number using a 4-digit code. And you can use the digits 0 through 9. Repetition is allowed, so then it should be 10, 10, 10, 10, which is 10,000. What is the probability that you and your friend have the same code? 1 over 10,000. Okay, so should I think about that differently? Okay, I'll show you kind of why it's like that. So you can pick any code, right? You can pick anything out of the 10,000s. But how many options does your friend have? Just one, because they have to pick the same one that you did. Okay, and then, wait, there's just a cancel on that. Three-digit code. Using these digits only. Repetition is not allowed. What's the probability that your code would be divisible by 2? So what makes our code divisible by 2? It has to end with a 2, a 4, or a 6. So you can separate these into scenarios. You could say, well, what if my code ended with a 2? What if it ended with a 4? What if it ended with a 6? In this case, they're all going to be the same. So, okay, so let's go. If it ended with a 2, or it ended with a 4, or it could end with a 6. So there's one option. If I put a 2, there's only one option to do that. Okay, if I've used the 2, how many options do I have left here? 6, and then 5. This would be the exact same thing. There's one option to put a 4. if you had just kind of done this way, because nothing would change, this would have just been a 3 options, which would be the same idea. Okay, but this is 90 out of, we have to always do probability out of. So forget the divisible by 2. How many codes are there altogether? How many all possible? Did you do 765? No. What? Did you do 654? Yeah. So this is just forgetting the whole sentence, just not the divisible by 2 part, just anything.
Why did you 761, not 65?
Because it's anything, all codes. I don't want divisible by 2 anymore.
Oh, okay.
I just want any single code ever possible.
Yeah.
Right? So that's why I say forget the reading. Don't read it now, just say. Okay, family has 4 children. What's the probability? At least one of them is a boy. Okay, you could do that crazy map that I think you guys all loved. Remember that crazy map? That we were like, boy, boy. Right? You could have done that. Okay. You could do at least one of them a boy, so you could do 1 boy, 3 girls, or you could put 2 boys, 2 girls in the family, or you could put 3 boys, 1 girl, or you could put all boys. So if I do that, if I have 1 boy and I have 3 girls in this family, there's a half probability of a boy, half girl, half girl, half girl. But what? I have to times that by 4, choose 1 by 4. Okay, why? Because your family could be a boy, girl, girl, girl family, or your family could have done girl, boy, girl, girl, or girl, girl, boy, girl. So you're saying there's 4 children, I'm choosing 1 of them to be a boy. So that would be 4/16. Or 2 boys and 2 girls, a half, 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 half. And what are you doing here? 4, choose 2. Because you have the 4 kids and you're choosing 2 of them to be a boy. So there are 6, that's 6, I think. 6, I'm not going to list them like boy, girl, or whatever. So 6/16. And then this one would be a 4, choose 3 scenario. In front of all that. So this boy, 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 boy family would just be a half, 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 half. And you don't have to do a multiplier on that because there's no other possible scenarios in that family, right? The order of those boy, 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 you can't be switching that around. Okay, And I'm going to quickly show you the other way, which I would have chosen, but if this makes sense to you, that's great. Okay, so again, the word complement means the opposite event. So all minus opposite event. So the all is 1. So I already know my scenario that there's 16 family options. So the all is 1, so there's 16 out of the 16. What kind of event is opposite of having at least one boy? No boys. So having at least one boy, the opposite is having the no boys. So a family that would have girl, 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 which is 1/2, 1/2, 1/2, 1/2. So that one's a little faster, right? Okay, and again, there's no choose multiplier because there's no other way to move those 4 girls around. You can't pick a different order than that.